roof, solar and trans gain through roof. Okay, yesterday till wall we have calculated. Now we are calculating for the roof. Okay. Now, so roof कभी भी top floor पे ही होता है sir. If you see this, ये ग्राउंड फ्लोर है, ये फर्स्ट फ्लोर है और सेकंड फ्लोर है. So for second floor we'll have roof. Okay, for first floor this is, for second floor this will be the floor, or for first floor this will be the ceiling. Okay, so roofs are always exposed to sun. Roofs are always exposed to sun, and roof will be on the top floor. Okay, now as we are calculating for the second floor, now we are calculating for the second floor, we need to consider the roof. Okay, as we are calculating the second floor, we need to consider the roof. Now as we need to consider the roof, we need to know the net area. So the net area of roof is length into width. The net area of roof is length into width. What is the length of the room? Length of the room is 12.16 feet and width is 10.41 feet, which is equals to 126.58 square feet. Okay, 126.58 square feet. Therefore, area equals to 126.58. What is Q? Q equals to A into U into delta T. Q equals to A into U into delta T. Now, U factor. To find the U factor, we need to know about the specification of the roof. We need to know about the specification of the roof. Roof is made of concrete with a mixture of sand and gravel aggregate of 6-inch thickness with suspended plaster and no insulation on the top of the deck. Okay, roof is made of concrete with a mixture of sand and gravel aggregate of 6-inch thickness with suspended plaster and no insulation on the top of the deck. So you can see from page number 9, here you can see the concrete. You can see the concrete and 6-inch, no insulation on the top of the deck with suspended plaster, which is 0.28. U factor is 0.28. The weight of the roof is 70 pounds per square feet. The weight of the roof is, for 4-inch it is 47, for 6-inch it is 70, for 8-inch it is 93. Okay, for weight of the roof is 70 pounds per square feet. Now delta T. So equivalent temperature difference delta T. Equivalent temperature difference delta T equals to T1 plus T2. T1 plus T2, where T1 equals to equivalent temperature difference and T2 equals to correction factor to equivalent temperature difference. T1 equals to equivalent temperature difference and T2 equals to correction factor to equivalent temperature difference. Now, therefore, weight of the roof is 70 pounds per square feet. Let's find out T1. Already yesterday we have calculated T2. T2 is 19 degree Fahrenheit, right? T2 is 19 degree Fahrenheit. So from page number 20, if you come to the page number 20, we have 4 different types of the roof. One is exposed to sun, covered with water, sprayed and shaded. So now we need to consider exposed to the sun. India mein roofs exposed to sun hota hai, and as it is 70, we are taking nearby 80 ka. Okay, 80 we are taking. As it is 80, now at 4 p.m. again at 4 p.m. Bye. At 4 p.m. it is 32. Okay, it is 32. T1 equals to 32 and T2 equals to 19 degree Fahrenheit. T1 equals to 32 and T2 equals to 19. Therefore, T equals to delta T equals to T1 plus T2, which is equals to 32 plus 19, that equals to 51 degree Fahrenheit. So as we have A U delta T, area equals to 126.51 and U equals to 0.28 and delta T equals to 51, which is 1806.56 BTU per hour. 1806.56 BTU per hour. So now ट्रांसिशन गेन, ट्रांस गेन एक्सेप्ट वॉल सनरूफ, हमें वॉल सनरूफ को क्या क्या फाइंड आउट किया, सोलार गेन एंड ट्रांस गेन फाइंड आउट किया. नाउ वी आर कैलकुलेटिंग ट्रांस गेन एक्सेप्ट वॉल सनरूफ. फर्स्ट वन इज ऑल ग्लास, फर्स्ट वन इज ऑल ग्लास. Same formula, A into U into delta T. In trans gain means the transfer, heat transfer from non-AC space to AC space. कभी भी नॉन एसी स्पेस से एसी स्पेस को हीट ट्रांसफर होता है, उसको हमें ट्रांस गेन बोलते हैं. See here we have two glasses in this drawing. We have two glasses, one is this glass and one is this glass. So already this glass is calculated. If you already this glass is calculated, but in this glass we have calculated only solar heat gain. Okay, in this glass we have calculated only solar heat gain, but transition we have not calculated. Now we are calculating transmission in this glass also plus in this glass also. Okay, both glasses we are taking. So we have two glasses in the north and east side. So area equals to 2 into 3, sorry, 2 into 3 into 4, which is 24 square feet. Two glasses, 24 square feet. Next, U factor. So in this case, U factor, we need to go with page number 10. From page number 10, विंडो में ग्लास वर्टिकल होता है, हॉरिजॉन्टल होता है. विंडो में ग्लास वर्टिकल होता है. सो वी कंसिडर वर्टिकल ग्लास विदाउट स्ट्रॉम. Without storm. Okay, we need to consider without storm as Hyderabad is far away from the seashore, हमें storm windows लेता है. So without storm, single pane, we didn't say it is double pane glass or triple pane glass. We didn't say it is double pane or triple pane. So it is a single pane. So single pane ordinary glass, we told it as a ordinary glass, single pane लेना. U factor equals to 1.13 BTU per hour. Next, delta T. Delta T equals to ODBT minus IDBT, which is 31 degree Fahrenheit. Therefore, QA into U into delta T for all glass equals to 24 into 1.13 into 31, which is 840.72 BTU per hour. After all glass partitions, we need to consider the partitions. What is partition? Partition is internal boundary. Partition is internal boundary for the building. The rooms है. Suppose here we have a AC space. Here we have a AC space, and this is the boundary. This boundary is considered as partition. Hope this is clear, right? Yes, this is called as partition. Now, if both are AC space, that means you are maintaining same temperature in both spaces. Okay, we are maintaining same temperature in both spaces, so no heat transfer takes place. So this partition will not be considered. Next, if one is AC's room and another one is non-AC, that means here the temperature will be more than the temperature in the AC space. Okay, so heat transfer takes place from this room to this room, so we need to consider this partition. Now in our drawing for this room, this is one partition, this is one partition, and this is one partition. Three partitions we have. In these three partitions, we consider In these three partitions, we consider only two partitions. This partition will not consider. Why we are not considering this partition? Because this is in between AC space to AC space. Clear? So we only consider this partition and this partition. Now we'll calculate the partition towards corridor. This is corridor and another partition towards the bath. So corridor net area equals to area of partition minus area of window. So iska area minus window ka area. So 10.41 the length into width minus the area of window, which is 112.92 square feet. So this is not corridor, this is bath. So area of partition minus area of partition minus area of door. This is area of door. This door. Therefore, 6.66. This length is 6.66 into 12 minus 7 into 3. Door ka area is 7 into 3, 21. Therefore, which is 58.92 square feet. Therefore, area equals to 112.92 plus 58.92, which is 171.84. 171.84. Next, U factor. U factor. Partitions are made of hollow concrete block with a mixture of sand and gravel aggregate of 8-inch thickness and both sides finished with 3 by 8-inch plastron walls with a mixture of lightweight aggregate. Okay. So from page number 7. From page number 7. So this is hollow concrete block with a mixture of sand and gravel aggregate of 8-inch thickness, 3 by 8-inch plastron walls, both sides finished with lightweight aggregate. This. So this is 0.31. U factor is 0.31. And delta T, here delta T is fixed, sir. ODBT minus IDBT minus 5 degree Fahrenheit. Okay, ODBT minus IDBT minus 5 degree Fahrenheit, which is 106 minus 75 minus 5, which is 26 degree Fahrenheit. Now, Q equals to A into U into delta T, which is area 171.84 into 0.31 into 0.28, which is 1385.03 BTU per hour. Next, floor. So same transmission again through floor. Here net area equals to length into width, area of floor, which is 126.58 square feet, and area. U factor we need to find. U factor, floor is made of floor tile with a concrete subfloor of sand and gravel aggregate of 6-inch thickness and half-inch sand plaster. So from page number 8, floor is made of floor tile. You'll get floor tile. Sand aggregate, here sand aggregate, 6-inch thickness, half-inch sand plaster, which is 0.57. Next, delta T equals to 0. Why delta T is equals to 0? See, listen. Very interesting concepts are this is. Ground floor, first floor, and second floor. Now, for second floor, this is floor, right? If first floor is AC, first floor AC है, तब इधर से हीट ट्रांसफर होता है क्या? नहीं होता है ना. हीट ट्रांसफर will not takes place through the floor. So the delta T for floor is 0. Suppose मैं first floor को calculate कर रहा हूं. I am calculating for first floor. तब ये हो जाएगा सीलिंग. ये हो जाएगा सीलिंग. If first floor is in the first floor I am calculating. Now I need to check whether second floor is AC or non-AC when I am calculating ceiling. If I am calculating in the second floor, when you come to the floor, you need to check whether your first floor is AC or non-AC. Okay. Now here first floor is above air conditioned space, therefore floor will become 0. Next ceiling. Ceiling का U factor and ceiling का U factor will be the same as U factor for the floor. Floor material और ceiling material same होता है ना. If you observe floor material, इधर ये floor किससे बनाया, same material से ceiling होता है. Okay, just the position, the location is changing. Clear? Now here ceiling का भी 0 हो जाएगा. The reason why ceiling is 0 is for the second floor we don't have ceiling, we have roof directly. सेकंड फ्लोर के लिए सीलिंग नहीं होता है, सीधा रूफ होता है, इसलिए हमें सीलिंग कैलकुलेट नहीं कर रहा हूं, सीलिंग का वैल्यू 0 ले रहा हूं. नेक्स्ट infiltration and outside air. Infiltration and outside air. Infiltration is the air which is defined uncontrolled air entering from the gaps of the doors and windows. Outside से inside, outside से inside as a gap से, from the gaps if the air enters, that is called as infiltrated air. From this air also the room heat is increasing, right? Outside air, hot air will be there. So as the room air is increasing, we need to calculate that infiltrated air also. So infiltration equals to CFM into delta T into 1.08. Infiltration equals to CFM into delta T into 1.08. So to find the CFM, we need to find the perimeter. To find the CFM, हमें perimeter of the door and windows को find out करना है पहले. ठीक है? What is the perimeter formula? What is the formula for perimeter? ఎందుకు
కాల్స్ కావాలంటే సంతలో
అదే సగమే వచ్చింది. What is the formula for perimeter? Two into width plus height. 2 into width plus height, which is equals to 2 into 7 plus 3 for door 20. Windows, window 2 into width plus height, 2 into 4 plus 3, which is 14 feet. Okay, now in this project, in this master bedroom, as we have, this is door, this is door, this is window, and this is window. As we have 2 doors and 2 windows, as we have 2 doors and 2 windows, now we need to consider only 1 door and 2 windows. Why? Because this door I am not considering again. The reason is it is in between AC space to AC space. The reason is AC space to AC space. So we have 2 doors, one door and 2 windows, which is 1 into 20 plus 2 into 14, 48 feet. As per ASHRAE, 1 feet can have a 1 CFM of air. So that 48 feet equals to 48 CFM. So delta T equals to ODBT minus IDBT, which is 106 minus 75. Therefore, infiltration equals to CFM into delta T into 1.08, 48 into 31 into 1.08, which is 1607.04 BTU per hour. Next, outside air. Outside air means this is the air intentionally we need to supply to maintain oxygen levels in the room. Intentional हमें एयर को सप्लाई करना है to maintain the oxygen level in the room. Now outside air equals to CFM into delta T into 1.08 into bypass factor. So to calculate the CFM, we need to calculate the ventilation CFM. Ventilation CFM is calculated with respect to number of people, with respect to area, with respect to air changes. Okay. People, area, and air changes. Now, so basically for master bedroom, I am considering 2 people. Okay. Normally we consider with respect to the area, but as it is a residential application, I am considering 2 people. And recommended from page number 21, recommended CFM per person is deluxe apartment, it is 30, and recommended CFM per square feet is 0.33. Therefore, people equals to number of people into CFM per person. So how many people we have? We have 2 people. 2 into 30, which is equals to 60 CFM. Next, area. Area into CFM per square feet, which is area how much? Master bedroom area 126.58 into CFM per square feet is 0.33, which is 41.71 CFM. Next, air changes. Volume into air changes divided by 60. So how will you get volume? Area, length into width into height. So 126.58 into 12. Height from floor to ceiling is 12, right? 126.58 into 12, you will get 1518.96. And air changes. For residential application, how many air changes we need to do? 1 air change. 1 air change per hour. If you convert into minute, 1 divided by 60, which is 25 CFM. Which is 25 CFM. Therefore, among these 3 values, which is the maximum value, हमें find out करना है. ये 3 values में 60 CFM is the maximum value. We have taken 60 CFM. And bypass factor, to find the bypass factor from page number 24, directly we take the residential application. For residential application, coil bypass factor is 0.3 to 0.5. So we are taking 0.4 as a bypass factor. And delta T equals to ODBT minus IDBT, which is 106 minus 75, that is 31 degree Fahrenheit. Therefore, outside air equals to 803.52 BTU per hour. Now, internal heat. In the internal heat, we have 3 factors. One is people, second one is lighting, and third one is appliances. So number of people into sensible heat gain per person. Lighting, area into watts per square feet, and appliances watt into 3.414. 1 watt equals to 3.414 BTU per hour. Therefore, people we have taken 2 people, lighting 1 watt per square feet, and appliances 400 watt. So these data will be given by the electrical engineer. हमको हमें कैसा इधर load calculations कर रहे, how we are performing the load calculations. The same way the electrical engineer also will perform electrical load calculations, and he will give this data. So from page number 13, heat gain from people. If we come to the heat gain from people, we are considering the people at office work. Sir, आप पूछ सकते हैं why you are considering office work? Because we are don't take this one, office work, because the apartments are included in the office work. Okay, So room dry bulb temperature. Room dry bulb temperature, how much we are maintaining? We are maintaining 75 degree Fahrenheit. So as it is 75 degree Fahrenheit, sensible heat gain per person, sensible heat is 245 BTU per hour. 245 BTU per hour. Therefore, number of people into sensible heat gain per person, 2 into 245 BTU per hour, which is 490 BTU per hour. Next, lighting. Area into watt per square feet into 3.414. So 125.58 is the area of the room. Watt is 1 watt per square feet into 3.414, which is 432.14 BTU per hour. Next, appliances. Watts into 3.414, which is 400 into 3.414, 1365.6 BTU per hour. Therefore, room sensible heat equals to solar heat gain through glass plus solar heat gain through walls plus roof plus all glass partitions plus floor plus ceiling plus infiltration and outside air plus people, lighting and appliances. So total value 10,609.36 BTU per hour. This is the room sensible heat. For room sensible heat, factor of safety will add 10%. After adding 10% of factor of safety, this is called as effective room sensible heat QS equals to 11,670.29 BTU per hour. Yeah, make a note. Once done, please let me know.
Done, sir, done. Done, sir. Done, sir. Done, sir. Done, sir. Done. Sir, can you please explain OBDT, ODBT, and and that IDBT?
ODBT means outside dry bulb temperature. Okay. IDBT means inside dry bulb temperature. In the starting, a psychometric table we have made yesterday. From there, we have taken this.
So, as per regional temperature, we have to.
Yes, yes.
Done, sir. 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 Done. Done, sir. Done, sir. Done, sir. Done. Done, sir. Sir, what is this BF?
Bypass factor. Bypass factor.
Sir, okay. Done, sir. Done, sir. Done. Done, sir.
सर इससे पहले जो वेंटिलेशन सेफन था वो वाला पेज को खोलना सर।
क्या?
सर ये वेंटिलेशन सीएफएम का जो कैलकुलेशन था ना सर वो वाला एक पेज मिस हो गया मुझसे।
हाँ।
हाँ ये सही वाला। Okay, sir, done.